Hi and Assalamualaikum. We are from Group 1 and today we are going to present about harmonic analysis and Fourier in practice. Before we proceed, let me introduce our group members, which is me, Noshika Natasha, Wan Ahmad Putra, Shafi Azim, and Nurin Farzana. The topic that we are going to discuss today is about harmonic analysis of cam follower oscillatory motion. Now, let's proceed to introduction. For introduction, what is harmonic analysis? According to Merriam-Webster, harmonic analysis is a predicate function that can be written as a sum of sine and cosine using the Fourier series. The application of harmonic analysis is widespread in physics, electrical and mechanical engineering, and also in computing. For example, vibrating string of guitar, ocean tide, sound wave, and many more. Next, cam and follower mechanism. A cam is a mechanism that rotates or oscillates to the second body that called as follower. This motion is known as reciprocating motion. Usually it found in IC engine and also in industry. For example, operation of the fuel pump in diesel engine, valve in IC engine, and many more. I think that's all for me. I will pass to Shafi Azim to continue his part. Thank you.
My name is Shafiq Azim bin Azli and I will continue this presentation with the background of study. I will explain about the experiment general purposes. Generally, this whole experiment was conducted to observe the entire movement of the camshaft and the followers that are attached with the different stiffness of the spring. Several data will be collected to get the value of critical speed for the camshaft such as the weight of the follower, angular displacement of camshaft, and etc. X is the experimental data involved in the harmonic analysis. Basically, there are two sets of experimental data that we use in this analysis. The first data is the revolution of the shaft itself, and the second data is the vertical displacement of the cam follower. Next, we will continue with the case of study that will be presented our friend Awan Ahmad Putra.
So the next subtopic is the case of study about the problem analysis with Fourier series and harmonic analysis. In the case of study, our group have two objectives, which are to determine the Fourier series of the given data to represent the movement up to the second harmonic with respect of the relationship between the variable in the problem. And the second one is to find the Fourier series in its standard form.
That's the problem statement. Here we analyze the relationship of vertical movement of cam follower in one revolution or rotation of 2 pi. The same interval 30 degree of rotation is studied. From the data given on the next slide, we find the Fourier series up to the second harmonic. This shows the data that we analyzed, which is dx, independent variable consists of revolution of shaft in degree. Then, dependent variable y is the vertical movement of the cam follower. Here we study 12 data to have the valid answer of rotation of 2 pi in the harmonic analysis.
Next is solution. In this part, we put all the collected data into the table and calculate the value of y arc cos SR, y arc sin SR, y arc cos 2 SR, and also y arc sin 2 SR. After that, we total up all the value into the last table and we got the value of y arc is 14.9, for y arc cos SR, negative 0.372, for y arc sin SR, negative 3.259, y arc cos 2 SR is 1.45 and the last one is 1.731.
Next, we will continue with the calculation of the Fourier series. So these are the first harmonic calculations. The difference between the first and second harmonic can be seen at both sine and cosinus degree value, which is 1 or 2. Also, the value of C1 can be said as the first harmonic, as the Cn is known as the nth term harmonic. After the equations being calculated, we obtain 2.48 for A0, 1.24 for C0, negative 0.062 for A1, negative 0.543 for B1, and 0.547 for C1, which is the value for the first harmonic equation. Then it is calculated that the alpha 1, which is represented as the degree value of first harmonic of the function, is on the third quadrant. The value is 186.51 degree.
Next, for the second harmonic, our group find A2 and B2 to get a value of alpha 2, which is 39.94 degrees. And the value is in quadrant 1, which is positive value. When we got the all answer, our group substitute in the equation fx to get the final answer is 1.24 plus 0.547 sin x plus 186.51 degree plus 0.377 sin 2x plus 39.95 degrees.
Result and discussion. We summarize the analysis of the Fourier series based on harmonic analysis and the data. This figure shows the graph of the vertical movement of cam follower versus rotation of shaft until 2 pi. Here, the graph is representing the function obtained by the predicted repetition of continuous interval of the shaft at 30 degrees. It also leads to the evolution of function waveform and shown as the cosine function. Here is the function fx defined for the revolution of a shaft of the cam follower. The coefficients of the relevant Fourier series are obtained from the set of readings based on the relationship between the fx and y. Thus, this Fourier series can identify the oscillatory component of the cam follower, which is the cam profile. Then we learn the harmonic analysis can analyze the steady-state response of the vertical movement of cam follower by the Fourier series obtained. So the Fourier series that we obtain here demonstrate the motion curves in the cam mechanism. Here we can see the cam profile in the mechanism of cam follower.
So the last one is conclusion. This is the conclusion from the report. The experiment's objectives were accomplished. The important thing is our group give 100% commitment to make sure the assignment has been done. So we can use the equation of simple harmonic series to find the final answer of Fourier series in harmonic analysis based on some equation above. Thank you for watching.